Okay, so you saw from the last video that when we integrated 1 over x using the integral test, the conclusion was that it was divergent. And when we integrated 1 over x squared, we got that the integral was convergent. So both of these series behave like their integrals. Again, the series do not converge to the value of the improper integral, but they behave the same way. So basically the p-series is a shortcut that is based off the integral test. If you have a series in the form 1 over n to the p, where p is the power, we're going to figure out by just defining what p is whether our series converges or diverges, and we're not going to integrate that specific series every time. So you can see from the screenshot that I did up above, and I've actually graphed the sequence, so you see 1 over 1, 1 over 2, 1 over 3, that yes, the sequence goes to 0, but it doesn't go to 0 fast enough because in the last video we got that that was divergent. When you come down here to the next screen, you can see how much faster 1 over n squared converges to 0. And it converges fast enough that not only does the integral converge, but the series converges as well. It's almost like a squeeze that we've put this underneath and you can see that it converges and the 1 over n does not. So what's the deal? What's the power? Putting in a third option, where is it? There it is, 1 over square root of n. So now we're looking at 1 over square root of n, which would be n to the 1/2. And then we have our 2 that we already have a conclusion on. 1 over n is divergent, and 1 over n squared is convergent. So because 1 over n squared is above a series that is divergent, and you can see that it goes to 0 even more slowly than 1 over n does, that it's going to diverge as well. And that's another test that we're going to talk about next class. And 1 over n squared was convergent. So if I ask you, what do you think 1 over n cubed would do, I would hope that you would realize that 1 over n cubed is going to be even smaller, even closer to 0, term for term, than 1 over n squared, and it would converge as well. So if you have a series in the form 1 over n to the p, we should be able to tell what's going on here. If p is equal to 1, we've also already come up with that was divergent. If in the case of 1/2 p is less than 1, that's divergent as well, and p greater than 1 is a convergent series. Okay? You can actually see this by the integration. When you integrate 1 over x to the p from 1 to infinity, we're going to rewrite that as x to the negative p when we integrate. And so we're going to add 1, whoops, and we have 1 over negative p plus 1, x to the negative p plus 1. So the whole business about why this converges is when we did the integral test, we ended up with infinity in the denominator. And infinity in the denominator goes to 0, and infinity in the numerator goes to infinity. So we want negative p plus 1 to stay in the denominator. In other words, we want it to be negative. We want it to be less than 0, so negative p is less than negative 1, and p then has to be greater than 1. And that's sort of a proof of why this works. So now all you have to identify is n equals 1 to infinity. I'm going to throw a little curveball here. Let's have 3 over n to the 5/3. Well, that's not in the form of 1 over. True that the numerator does not impact it at all, but to do this right, we're going to pull that 3 out. Now it's in the form of a p-series. I want you to tell me what p is, even though it's obvious. Then I want you to compare it to 1. 5/3 is greater than 1, therefore converges by the p-series test. And you would do that the same way if you had a power that was less than or equal to 1. You would say that it diverged by the p-series test. Careful not to use the p-series for things that aren't the p-series. An easy fix was the coefficient coming out front, but if you have 1 over n squared plus 1, you can't use the p-series. We would go back and integrate that one for right now with arctan. There are other tests down the road that's going to fix that issue, but don't use the p-series. This is not in p-series form. And you shouldn't have one of those on this. Maybe you would if, again, you could use the integral test. Hope this helps, and I will see you next week.